All right, people, welcome back. We're going to start our new unit on factoring. So this week we will look at the different types of factoring. Towards the end of the week, I'll make a flow chart that you can kind of follow your way through the different types and know how to factor specific different types. There are tons of different ways to factor. It all depends on which way you're comfortable. Pick away and just go with it. You don't need to know how to do different types, just whichever way is best for you. Some of the way in the notes are written. I change them a little bit, but you'll see as I go along. If you don't like my way, I'll show you different ways, but I'm gonna go through the way that is comfortable for me, and if you need more help, please make sure you're talking to me. So, factoring quadratics. It's important to note that factoring does not change the value of the quadratic. It is just changing the way the quadratic is written. So if you multiply or factor from the quadratic back out, you will always get your original quadratic. As you can see in those two examples, just distributing it. They go across, so this is the quadratic form. That is its factored form, same thing here to there. They don't go up and down, so be careful with that. You'll hear me say a bunch of different things, just kind of grasp it. If you need help, pause it and let's go for it. So first thing, always look for a GCF first when factoring. GCF is the greatest common factor. So in a sense, it is the largest number and or variables that go into every single term. So you always want to do that at the very beginning. You want to try to find a GCF, see what's in common. So if we're looking at these, 4x to the fourth plus 12x to the third. So if I'm looking at 4 and 12, the biggest number in common in 4 and 12 is 4. If I look at x to the fourth and x to the third, variables are easy. It's the smallest exponent, so x cubed. So my GCF here is 4x cubed. That is the largest number that is in common in both of those entries. Now, if I take 4 away from 4, I'm left with 1. If I take x cubed away from x to the fourth, I take 3 of those 4x's away, I'm left with just an x. Still got the plus sign. So if I take 4 away from 12, 12 divided by 4 is 3, and I took all my x cubes away, so that is the factored form. So if I'm looking here, that whole thing, that is your new factored form, and what's in the parentheses should not have a GCF anymore. So if I'm looking 3 terms, 10y squared plus 4y minus 64. So if I look, I start with my smallest number 4. 4 doesn't go into 10, so then another factor of 4 would be 2. I can take a 2 out of everything. If I look, my last term does not have a y, so 2 is just going to be my GCF. If I take that out, I'm left with 5y squared plus 2y minus 32. And you see 2 and 5 don't have any factors, so I'm good there. So I'm just looking for GCFs. So here, if I'm just factoring out the GCF, I'm looking at 16 and 8. So 16 and 8, if I'm looking at 8, 8 goes into 16 evenly, so I'm good to go. X's, I got 1x, I got 5 x's, so I can take out an 8 and I can take out an x. If I do that, 16 divided by 8 is 2. X to the fifth divided by x, so I subtract. 5 minus 1 is 4, so I got x to the fourth left over here. Now, an important thing is I took out the entire 8x, so I need a placeholder. So if I take everything out, I'm going to put a 1, not a 0. I need that placeholder. So that is my GCF. I'm looking at pulling out a GCF first, and we're going from there. So when factoring any polynomial, you're always going to check for a GCF first. So when do I use this? When factoring, I'll skip this, I'm sorry. When factoring anything in a big, always check for a GCF first. That's very, very, very important. It's going to simplify everything for you. All right, next thing, factoring using X factor. You can use this. I'll show you a T-chart in a second. When we get down to example 3, I'll show you a T-chart. It's the same kind of concept. But when do I use this? We're only going to use this for quadratics. remember, quadratics has 3 terms. So x squared, x, and nothing. And also x squared does not have a coefficient. That's an O. That's a big star too. X squared does not have a coefficient. The coefficient is 1. So I guess it does. It's just a 1. There's nothing in front of it. So the way this works is I'm going to create my x. I'll scroll in here so you can see more. And I'm going to put my 24 up top. And I'm going to put my middle term on bottom. So basically you're trying to find here what multiplies to get 24 and adds to get 10. So what 2 numbers multiply to get 24 and add to get 10? So that's going to be a 6 and a 4. So what multiplies to get the last number? It doesn't matter which do it. So multiplies here to get and adds to get this, because it is a plus sign. So here, my 4 and my 6 are both positive. So I have my x factor, it's factored, we're good to go. So if I'm looking at another one, the more you do, the easier these become, I promise you. So 6 goes up top, negative 5 goes in the bottom. So what multiplies to get 6 and adds to give you negative 5? So that's going to be negative 3 times negative 2 gives me positive 6 and adds to give me negative 5. So x minus 3 and x minus 2. All right, now over here, we got negative 40 and negative 3. So now I have a negative up top. So one side's going to be positive, one side's going to be negative. So what multiplies to give me negative 40 and adds to give me negative 3? So that's negative 8 and 5. So x minus 8, x plus 5. Or it doesn't matter, you can write x plus 5, x minus 8. Order doesn't matter as long as the signs stay with the same number. I know I'm going kind of quick, but you can pause and look at it if you want to. So here, 6 is on top, negative 7 is on the bottom. So what factors does 6 add to give you negative 7? So that's going to be negative 6 and 1. So x minus 6 and x minus 1. When we get down in the next section, I'm going to show you a chart that I use that is a little bit more user-friendly for me, but you can still use the x factor as well. So I'll show you both ways. Oh, ran out of space. So now, this is factoring using the bottoms up. When do I use this? This is only for quadratic. And this is when your x squared is greater than 1. So basically, you have a number in front of the x squared term. And it's going to be positive. So here's your step 0. I put that as step 0 because you always want to do that first, no matter what. Before you get into it, you always want to check for a GCF. Then you can kind of read through it, multiply the first and last term, and that's going to be your x factor. So if I do this first one, x factor, you can look at it. So 6 times 3 is 18 and 11. So what factors of 18 add to give you 11? That's going to be 9 and 2. So what we just previously did, we got x plus 9 and x plus 2. Now, if I multiply that out, I'm obviously not going to get the first term because x times x is not 6x squared. So what I'm going to do is I'm always going to take this and I'm going to divide by the very first leading coefficient. That's 6 in this case. So I'm going to go ahead and reduce the fractions. So that's going to be 3 over 2. And once I had the fractions reduced, this is your bottoms up. I'm going to take the bottom of the fraction, kick it up front. So 2x plus 3. Take the bottom of the fraction, kick it up front. So 3x plus 1. And there you go. You have it every time. Now, if I take this, come over here. This is a different way I like to work it. So 6x squared plus 11x plus 3. You have these same basic concepts, but I like T-charts better. So I always look at this. A times C and B. Excuse me. So in this case, I'm looking at this is ax squared plus bx plus c is my general form for a quadratic. So if I'm gonna get my chart, I'm gonna say a times c, so 6 times 3 is 18, and then my middle term is b. I always look here too. What is the last sign? The last sign is what I'm gonna do in my chart. Okay? And I can make you a list here. So the last sign is what I do in my chart. So here I'm gonna add. So if I'm gonna add, my last sign is positive. I'm gonna add, my signs are the same. So they're both gonna be positive. So factors of 18 add to give me 11, 9, and 2. So 9 times 2 add to give me 11. So I got x plus 9, x plus 2, and I'm at the same spot I was. So divide by 6, so you get 2x plus 3. Oops, and 3x plus 1. So you still get the same solution. It's just a different way to organize than the x. If you like the x, go for the x. I have a mental block against the x. I like my T-chart, and I could show you different ways where you don't need the signs. So in my way, if you're looking here, if there's a plus in the back, it means two things. One, you're gonna add in the chart. Two, my signs are both the same. Well, that's sings, that's not signs. And then you look to the first part. So the first symbol is a positive, so they're both positive. And I'm gonna put that, look. First symbol or sign. Now, on the contrary, if it is a minus in the back, we're going to do the opposite. We're going to subtract in the chart. So if I'm subtracting, my signs are opposite. And then here, your larger factor get your first sign. This is how I deal with my chart, and your chart is always A, C, B. So this is how I like to factor, but that is just my opinion. This is how I'm going to do it in class. If you want me to do the X factor, I will be glad to. But this chart and this little reference is what I use all of the time. Once you get it, it just kind of simplifies things. So if I'm looking at this one, so 3x squared minus 2x minus 8. First of all, I want to look for a GCF. Nothing's in common here. So I'm going to build my chart. So a times c, 3 times 8 is 24, minus in the back to give me a 2. So what factors of 24 subtract to give you 2? That's going to be 12. No, it's not at all. Subtract to give you 2, that's going to be 6 times 4. I like this method because I can do 12 times 2 gives me 10. That doesn't work when I subtract. 8 times 3 is 5. You can keep going. That's the one that works. So according to what I just did over there, if you want to write that down and keep it in front of you while you're used to it, minus in the back, so I subtract. That also tells me my signs are opposite. So I got one positive, one negative. And this sign always goes to the larger factor. So since that's a minus, that gets the 6, that gets the 4. And then now I'm going to do the same thing I would normally. So divide by 3. So 3x plus 4, because that doesn't reduce, so I kick it up. 6 divided by 3 is 2, so I just subtract or divide it. 6 minus 3 is 2, and we are good to go here. And that is factoring in a nutshell. So B, look for a GCF. No GCF. So 6 times 5 is 30. I'm going to add, because there's this plus in the back. What factors of 30 add to give you 17? 15 times 2 adds to give you 17. If you don't know it, just start listing. 10 times 3 is 13 until you find one that works. That's why I like the chart. You don't have to erase. You just keep listing and listing and listing. So now, plus in the back means my signs are the same. They are both going to be positive, so I can start there. So you're already 4/6 the way through. 15 and 2, they're the same, so it doesn't matter where they go. Now I'm going to divide by my a term, which is 6. So reduce your fraction, so divide by 3, so 5 over 2. Divide by 2, 1 over 3. Now you play the kick-up game. So 2x plus 5, and then 3x plus 1. And we're good to go. This method works every single time. You just got to practice, 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 and get it down. So C. First of all, I want to look at a GCF. What's in common here? They are all divisible by 2. So I simplify that. This 2 right here is just going to tag along the whole time on the outside. It's just going to stay there. We're not going to worry about it. It's going to tag along. This part right here is what we're going to factor. So a times c, 4 times 3 is 12, minus in the back to give me a 1. So n plus and minus, and go ahead and set it up. One's positive, one's negative because there's a minus in the back. So what factors the 12 subtract to give me 1? 4 times 3. This is a minus sign as well. They don't go together, but since that's a minus sign, it gets the larger factor, so 4 and 3. Now all I gotta do is divide it by the 4 from here. So I got 4n plus 3, 4 divided by 4 is 1. And then I always have to remember to bring my GCF back down. There you go. All right, last one over here, and then we're gonna put it all together. So I got 3x squared plus 13x, 13's prime, so a times c, 3 times 12 is 36. Add in the back to give me 13. So what factors of 36 add to give you 13? 9 and 4. So x plus 9, x plus 4, they're both positive, because that's right there. Let's divide them by 3. So I end up getting an x plus 3 and a 3x plus 4. And there we go. So factoring this once again over here goes through my chart. So plus in the back means you're going to add in the chart. The signs are the same. They're both the same as the first symbol. So whatever symbol is in front of the BX, the positive or the negative. If it's a minus in the back, they subtract in the chart, and your signs are opposite, and the larger factor gets the first sign or first symbol. All right, last 3. Let's put it all together. All right, so the first one, 3a squared plus 27a plus 60. I know I've taught a lot, but let's knock these out. So GCF, what's in common in all of them? I can take out a 3. So a squared plus 9a plus 20. There's no a in the last term, so I'm good to go. So nice and simple. You can do your x factor here. What factor is a 20? Add to give you 9. That's a 5 and a 4. So they're both going to be positive. There's no a term here now, so I don't have to divide it, and you're good to go. If there's no a term, once you get your factors out of the chart, you're fine. You can move on. So B, what's in common in all of these? 45 and 350. I don't think 45 or 9 goes into 350, so let's just take out a 5. And I can also take out an m squared, that's the largest. So that gives me a 9m squared plus 9m minus, take that out, what's that, a 70? And we're good to go. All right, so that's my GCF, that's gonna tag along. So let's do my chart, a times c. So 9 times negative 70 is negative 630. But in my chart, I don't want to use the negative signs. That's just there. So 9 times 70 is 630. I'm going to minus to get 9. Minus in the back, so I get 9. That minus in the back also tells me that my signs are going to be different. So I got a plus, I got a minus. So what factors of 630 subtract to give you 9? 30 and 21. Yeah. So it's a plus, so the plus gets to 30, 21. 30 minus 21 is 9. That's a quick way to check. Now I want to divide them by 9. So bring this guy down. Let's divide these by 3. So 10 over 3. 7 over 3. So 3m plus 10. Whoops. Sorry. 3m minus 7. So big numbers. If you can do this one, you're good. And then bring down your GCF. So 5m squared. And you are finished. So big numbers. That's all I can do to make it harder is just give you bigger numbers. Now, with two terms, we'll get into more specifics about these tomorrow. For today, they should be very simple. What is the GCF? That's all you can do. So if I look here, 9 and 3, I can take out a 3. My r's, r squared and r, I can take out an r. So that leaves me with a 3r. And the first one, 9 divided by 3 is 3. R squared divided by r, you subtract the exponent. 3r is completely done, so you leave a placeholder 1. So make sure you either like the x factor, and you can do it this way. I did it up here if you like it, or you can come over here and you can do the ACB chart. This is what I like. It's organized. It takes a little bit longer, but it's organized. It's good for your thought process, and it kind of gives you a way to do a sign so that you don't confuse yourself. So take a little while, practice. The more you practice, the easier factoring gets. If you're not going to practice, factoring is going to stay hard, and we're going to use it the rest of the year. So you need to spend the time on it now and get good at it. So if you got questions, please let me know. Other than that, I will talk to y'all later. Hope you have a wonderful rest of the day.